robots are starting to break past the limits we thought they had. At Berkeley, engineers have built a shape-changing robot that twists into entirely new forms. In China, a soft robot lighter than a grain of rice runs across water and hauls cargo. Korea is unveiling a humanoid with an AI brain. Hollywood is testing its first digital actress. Seoul just hosted robot sports, and shipyards are crawling with spider-like welders while humanoids walk city streets with no cameras. Wild times for robotics. So let's talk about it. Alright, so one of the biggest breakthroughs comes from UC Berkeley. Their team, working with Carnegie Mellon and Georgia Tech, developed an AI-driven design tool for what they call meta-trust robots. These are robots built out of hundreds of beams and joints, kind of like a mechanical skeleton that can twist and fold into new shapes. The idea is that the robot can morph itself depending on the task. You could make a quadruped that folds into a different shape, or even a helmet that reshapes itself to protect different parts of your head. The catch has always been control. Add more actuators and the complexity shoots up. Traditionally, engineers would manually group actuators into networks, but that process is brutal, tedious, slow, and honestly not scalable. That's where the AI comes in. The Berkeley team used a genetic algorithm to figure out the minimum number of control units you actually need to get the robot doing complex tasks. The system can basically explore every possibility and spit out an optimized setup. Instead of needing hundreds of independent control channels, the algorithm identifies a sweet spot where you can still hit all your performance goals, shape-shifting, locomotion, object manipulation, while keeping the number of channels low. The results were wild. They built prototypes ranging from a lobster-inspired walker to a tentacle actuator, and they all managed these complex shape transformations with way fewer control units than anyone expected. Senjugu, who led this study, compared it to muscle synergy and biology. Your body doesn't control every muscle fiber one by one. It groups them into coordinated units. The AI does the same thing with actuators, and honestly, the researchers were surprised at how well it worked. They started with simple locomotion, just making a robot run as fast as possible, but ended up with this whole framework for designing morphing machines. Now they're talking about layering generative AI into the process. You could feed in your body dimensions. Say you want a helmet that can change for different situations, and the system could just auto-generate the design and the control logic. The long-term vision is even crazier. Yao, who runs Berkeley's Morphing Matter Lab, talks about everyday objects that can morph like robots. Bed sheets with truss structures that can turn patients in hospitals, squeeze them like a massage, or chairs and wearables that adapt on the fly. It really makes you rethink what counts as a robot. Meanwhile, over in China, researchers at Guangdong University of Technology and Guang Polytechnic Normal University have been working on something way smaller, an 8-mg soft robot that responds to 3 different environmental triggers: heat, humidity, and magnetism. Most soft robots until now could only react to a single trigger, like light or heat, which limited them to one environment, land only or water only. The moment you tried to mix signals, the responses would clash and performance would tank. This new design solves that. They built it using a polyamide film chemically treated to create a polyamic acid layer that reacts strongly to heat and humidity. On top of that, they added a silicone rubber layer embedded with neodymium iron boron magnetic particles. So, you've got this triple layer sandwich that gives it sensitivity to temperature, moisture, and magnetic fields all at once without the signals interfering. That's the big breakthrough, keeping the responses separated and reliable. Even though it weighs only 8 mg, it's surprisingly capable. On water, it hits speeds of 9.66 cm, which is about what you see from real whale-eye gig beetles. On land, it uses a rolling gait when driven by a rotating magnetic field, letting it climb slopes and move seamlessly between land and water. It can carry 5 times its own weight, so for demo purposes they had it move a tiny pebble across mixed terrain, drop it off using a pulse of near-infrared light to trigger a shape change, then retreat back under magnetic control. Full pickup, transport, and delivery cycle. For something that small, that's insane. The practical applications are obvious. Swarms of these could check submerged structures, monitor wetlands, help in disaster response, or even work inside the human body someday. The researchers pointed out that soft robotics has exploded recently, with groups in South Korea already building swarms that unclog tubes using magnetics. The key difference here is multi-response capability in one tiny machine. That's what unlocks new environments. Alright, now you've seen plenty of AI website builders before. Most leave you with generic templates and endless tweaking. But Ready, who are sponsoring today's video, actually delivers a finished site that's ready to launch. You describe your idea, whether it's a store, a business, or just a landing page. And in minutes, you get a professional website that's mobile-friendly, SEO optimized, and instantly publishable. And yes, you can edit anything, but you're starting from something that feels complete right away. Ready even handles hosting, custom domains, and SSL security, so you don't have to worry about messy setup. What really stands out is Ready Agent. It engages visitors in real time, holds natural conversations, captures leads instantly, and even books appointments for you. It can send emails, adapt to different customer needs, and basically work as a 247 teammate built right into your website. On top of that, Ready includes image editing, form builders, and advanced SEO tools. So your site isn't just online, it's optimized to grow. So if you've been thinking about launching a site, stop wasting time on complicated tools. Click the link in the description, try Ready for free, and get your website online today. Now let's scale way up from milligs to full humanoids. In Korea, the Korea Institute of Science and Technology, KISS, together with LG Electronics and LG AI Research, just announced they're unveiling a humanoid robot in November. It's called CAPEX, and it's powered by LG's EXA-1 vision language model as its brain. CAPEX isn't just about mimicking human movement. It's got human-level physical capabilities, including a multi-finger robotic hand with tactile sensitivity that matches human touch. It uses reinforcement learning plus vision language AI for learning and adaptation. The big pitch here is physical AI instead of AI just working in a simulated environment. Physical AI means it learns directly in the real world, adapting to dynamic environments. That's the foundation for robots that can truly collaborate with humans across industries, households, logistics, manufacturing, healthcare. The United States and China currently dominate the humanoid platform game. But KISS and LG are positioning CAPEX as Korea's independent play to set a new standard. Lee Jong-won, who runs KISS's humanoid research division, said CAPEX could become a practical alternative that challenges the United States-China market structure. They're planning field demonstrations and commercialization within 4 years, and by developing core components domestically like high-output actuators, Korea is reducing reliance on foreign suppliers. So the national strategy here is clear. Humanoids is both tech and geopolitical leverage. But while Korea is pushing humanoids for industrial and household use over in Hollywood, AI is already making headlines in entertainment. At the Zurich summit tied to the film festival, a virtual actress named Tilly Norwood was introduced by London-based studio Particle 6. She's a synthetic character promoted as the next Scarlett Johansson. She has brown eyes, a British accent, her own Instagram, and her debut was a short parody sketch called AI Commissioner with 16 AI-generated characters. She was front and center. The video got over 600,000 views, but responses were brutal. People called it creepy, awkward, unfunny, with glitches like blurred teeth and stiff dialogue making it worse. Still, Particle 6 says interest is picking up. Talent agents who dismissed it months ago are now curious, and they're hinting at an agency deal soon. Not everyone is happy. SAG-AFTRA, the union representing 160,000 United States performers, came out swinging. They said creativity must remain human-centered, and that Norwood is not an actor, but a software product built on work from real performers without consent or pay. Remember, SAG-AFTRA had tense contract talks in 2023 and 2024, and protections against AI replication were a core issue. The union warned then that technology moves faster than regulation, and Norwood proves their point. Industry experts are also skeptical. Yves Bergquist from USC's Entertainment Technology Center said the hype is nonsense because stars like Scarlett Johansson bring fan bases. Synthetic actors don't. Studios already use AI for DJing and doubles, but going full synthetic might not click with audiences. Still, the trend is undeniable, and Norwood is now a test case for whether Hollywood ever accepts AI-only stars. Back to Korea this time, Seoul hosted its first AI robot show at Coke's in Gangnam, and it looked more like a sports festival than a tech fair. 73 robotics companies showed up, and one of the main attractions was a humanoid sports tournament. Robots competed in archery, sprinting, weightlifting, and a traditional Korean stone-striking game called bisaki. 22 teams joined, including groups from Taiwan and Indonesia with Fiera, the Robot Soccer Association overseeing. The archery event had humanoids shooting arrows at spinning targets with crowds cheering and phones up everywhere. Elsewhere, Korean university teams brought extreme robots built for emergency deployment. These had to navigate stairs, scattered bricks, smoke bursts, and uneven terrain. One team from Kwangwon University had a robot using object recognition to adapt in real time, capable of lifting objects and pressing buttons with its arms. That same team has already won contests and even represented Korea at RUCUP 2024 in Hobville. The show wasn't just serious competition, though. There were participatory events like exoskeleton races where YouTuber Horse King tried to beat his record of moving 22 racks in 100 seconds using spring-powered exosuits from Angel Robotics. Crowds also gathered for an AI board game zone where people played Omak against a machine, and even for challenges against a robotic arm threading needles. The point was to make robotics approachable, letting kids, families, and professionals all interact with the tech. Seoul's deputy mayor said the whole idea was breaking stereotypes of robots as distant or abstract, and instead showing how they might coexist with people day to day. Finally, one more big update also from Korea. This time out of KAIST, where startups are pushing robotics directly into industry. Dindin Robotics unveiled their Shanwol robot system, a spider-like crawler that can move across steel walls and ceilings in shipyards. Their quadruped Dindin 30 has foot-shaped magnetic feet and is being upgraded to handle welding and painting tasks by 2026. It already passed tests at Samsung Heavy Industries, stepping over stiffeners on ship hulls, and they've got partnerships with Hyundai Samo and Hana Ocean too. The idea is to deploy robots into high-risk jobs, solving labor shortages and automating heavy industry. Meanwhile, your robotics is focusing on humanoid walking. Their demo video showed a robot walking naturally through the crowds in downtown Gangnam. The secret is a blind walking controller. Instead of relying on cameras or sensors, the robot uses internal systems to imagine the ground, keeping balance on sidewalks, stairs, slopes, and in any weather. That's a big shift. No dependence on external sensing, just internal modeling of terrain. Your robotics plans to push this tech for both indoor and outdoor industrial applications. So here's the question. If you had access to these tiny insect-sized robots and those shape-changing machines, what's the most creative way you'd put them to use? Drop your best ideas in the comments. I really want to see how far you'd take it. And while you're here, don't forget to subscribe and hit the like button. It helps a lot. Thanks for watching, and I'll catch you in the next one. Joined, Inco.